Macam mana ni? Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera. With me, Madam Normadia binti Syafiee, your physics lecturers, and today I will discuss with you all about subtopic 3.5, which is resistors in series and parallel, 3.6 potential divider, and 3.7 potentiometer. Let me start with subtopic 3.5, which is a resistors in series and parallel. The learning outcome for this subtopic, students can derive and determine the effective resistance of resistors in series and parallel. Okay class, as we know that resistor is the most important component in electrical circuit. So what is the function of resistor? Resistor is used to control the amount of current flowing in the circuit as safeguard to the vital component in the device. We can measure the resistance in unit ohm. The individual standard resistor can be combined to get the effective resistance, so we can combine it either in series arrangement or in parallel arrangement. Alright class, look at this circuit. This circuit consists three resistors, which is R1, R2, R3, and also power supply. We can say that this arrangement is series arrangement when one beside to other connected end to end, and then they are connected with the terminal of power supply to form a complete circuit. In this arrangement, the current is constant and flow through all resistors R1, R2, and R3. As a result, we can see that the current in this circuit are same, which is I total equals to I1 equals to I2 equals to I3. And guys, how about the voltage drop? The voltage drop across all the resistors. Okay, for resistor 1, we can label as V1. For resistor 2, we can label as V2. And for resistor 3, we can label as V3. On the other hand, the sum of the voltage across all the resistors is equal to the voltage applied. We can write as V total or V apply equals to V1 plus V2 plus V3. And now class, we can find the equivalent or effective resistance.
line itu.
Alright. We continue, we continue our discussion for this subtopic. Okay, we can find the equivalent resistance or effective resistance by using the formula of V total is equal to V1 plus V2 plus V3. And according to, okay class, we proceed to another slide. Another combination is a parallel combination. Look at this figure, we can find out that each resistance or the end of each resistor is directly connected to the terminal of power supply to form a complete circuit. So the voltage drop across each resistors are same. We apply voltage, which is a V total equals to V1 equals to V2 and equals to V3. But the current in these circuits are not same because current is divided into different paths at the junction. So this is a total current that flow across or through all the resistors equals to the total current. We can write as I total equals to I1 plus I2 plus I3. And now class, we can find or determine the effective resistance in parallel arrangement. Okay, which is a come from I total equals to I1 plus I2 plus I3. And again, we refer to Ohm's law, I equals to V over R. And we rewrite the equation. V over RE equals to V over R1 plus V over R2 plus V over R3. In this arrangement, potential difference are same, so we can cancel up at both sides, and finally we get I or 1 over R effective equals to 1 over R1 plus 1 over R2 plus 1 over R3. And then don't forget to rearrange the equation to get the effective resistance. Okay, comes we try to solve one problem. What is the equivalent resistance of these resistors in figure below? Okay, first of all class, you need to recognize either the circuit is in series arrangement or in parallel arrangement. So since this circuit in series arrangement, we just use the formula R effective equals to R1 plus R2, and then you substitute the value of R1 and R2 into the equation. And finally, we will get the final answer with the unit, which is a 5 ohm. Don't forget to put the unit. Oh, we have another problem. What is the equivalent resistance of the resistors in figure below? So first, we need to analyze the types of the arrangement. We found that in this circuit, this is the combination arrangement. We have parallel and series arrangement. So what you need to do is, first you need to solve the furthest resistor from the battery or cell. Okay, in this case, R2 and R3 is the furthest resistor from the battery. And then we found that R2 and R3 we arrange in parallel. Since in parallel, we just use the formula 1 over R23 equals to 1 over R2 plus 1 over R3. And then you substitute the value of R2 and R3. and you can get the effective resistance for R23, which is 18.75 ohm. Class, we don't finish yet. Okay, we want to find the effective resistance for the circuit. So we have another resistance which is R1 and R4. So what we need to do is R1, R4 and the combination of R23 actually we arrange in series. So we use the formula for series arrangement, which is R23 plus R1 plus R4. You substitute the value for R23, R1 and R4, and then we get the final answer with the unit, which is 58.75 ohm. Alright class, don't waste our time. We proceed with a next subtopic, which is a 3.6 potential divider. In this subtopic, we have two learning outcomes. First, student can explain the principle of potential divider. Second, student can use the equation of potential divider. What is the potential divider? So, potential divider is a device that used to split, divide, or remove any desired smaller portion of voltage from a single voltage source. We can set up potential divider by connecting a variable resistor, which is we arrange in series to a voltage source. Look at this schematic diagram, which is we have two resistors, R1 and R2, in series arrangement connect with voltage source, which is V0. Okay, V1 is a portion or a fraction that we want to take out. And at this portion, we can connect with a load which is have less voltage from voltage source such as lamp, etc. There are voltage between point A and B. So the voltage between A and B can be divided into voltage AC and CB. Right? Can you look at for this one? V1 is voltage AC, V2 is voltage CB. So we can take the ratio of the resistance, give the ratio of voltage, which is a V across over V0 equals to R over RT. V across, which is a voltage across the resistance, V0 is a voltage source, and RT is stand for total resistance. If you want to find voltage V1 or across R1, you can just use the formula R1 over R2 plus R1 times with V0. Why? We take R1 plus R2. Okay, again, you look at this figure. Okay, R1 and R2 is in series arrangement. We want to find the total resistance. So we just plus both resistance. If you want to find V2 or voltage drop at R2, okay, you just replace resistance 2. Let me try to solve this problem. In the following circuit, find the potential difference across each resistor. Alright, look at this schematic or this circuit. We have two resistors which is in series and connected with a power supply with a voltage 8 volt. The question asks us to find the potential at each resistor. So we want to find V1 and V2. According to the potential divider, we just use the formula V1 equals to R1 over total resistance or R1 plus R2 times with applied voltage. Then you substitute the value of R1 and R2 and apply voltage into the equation. And finally, you will get the final answer, which is a 3.2 volt. And if you want to find voltage at R2 or V2, we just replace the value of resistance, which is we use resistance 2 or R2 into the equation. Then you substitute the value of the equation, the value of resistance. Okay, class, we proceed with last subtopic, which is 3.7 potentiometer. In this subtopic, we have two learning outcomes. Okay, first, student can explain principles of potentiometer and its applications. B, student can use related equation. Sorry, my PowerPoint so faster. Okay, so okay. Okay, what is a potentiometer? We have three functions of potentiometer. First, we want to measure unknown EMF of cell. We want to measure unknown EMF by comparison with a known EMF, and we want to measure internal resistance of a cell. Okay, look at this schematic diagram. We have a galvanometer to detect the current. We have the unknown EMF. We have the voltage supply. And we have a uniform wire, which is AB or resistor AB. Okay, potential divider between point AB can be divided into VAD and DB by adjusting the slider or the contact wire at point D. Okay, when galvanometer equals to 0 means there's a balance point, no current flow through galvanometer. So the potential at point AD equals to EMF X or unknown EMF. Okay, now I want to show some steps in taking measurement by using potentiometer. First, we connect the unknown EMF in series with galvanometer. Then, we adjust the slider until the galvanometer equals to 0 or balance point. When galvanometer equals to 0 means there is no current flow through galvanometer, and the potential difference at point AD equals to unknown EMF, which is we can write as EMF X equals to IRX. I stands for current that flow through point AB. Rx is resistance between point AD. Then we replace the EMF X or unknown EMF with a standard battery or known EMF, which is a EMF S. Then we repeat the procedure, okay, until galvanometer equals to 0. So we will get the EMF S equal with IRS. I is current, same current, which is a flow across point A, B. And RS is the resistance for a new section when we use known EMF. By taking the both equation EMF X and EMF S, we can ratio it. Okay, EMF X over EMF S equals to IRX over IRS. Did you notice that the current that we use in this circuit is same? So we can cancel up for the current and we get EMF X equals to RX over RS times with EMF S. Okay, again, EMF S is unknown EMF. Rx is resistance at point AD. Rs is a resistance for the new section and EMF S is the known EMF. Since the resistance in the wire R is directly proportional to the length, the relationship can be written as EMF X equals to Lx over Ls times with EMF S. Ls is stand for length along point AD. Okay, sorry. We proceed with an example for potentiometer. Okay, the circuit above shows a potentiometer connected to a wire PQ of length 100 centimeter and resistance 5.5 ohm. When the galvanometer is balanced, find the length PJ. Okay, first of all, we list down the information from the question, which is we have length PQ 100 centimeter, resistance PQ 5.5 ohm, voltage PQ 2.5 volt and voltage PJ equals to 1.8 volt, which is equals to EMF 1 because of the galvanometer is balanced. We want to find length of PJ. So what we need to do is we will apply the equation VPJ or Vx over VPQ equals to LPJ over LPQ. And then you substitute the value for VPJ, which is 1.8 volt, and VPQ 2.5, and LPQ 100 centimeter. Rearrange the equation to get length of PJ, which is 72 centimeter. Alright class, so we have finished our lecture chapter 3 and don't forget to click the link or scan this QR for your attendance. That's all. Thank you.